This video is supplemental to week 6 and 7 material. It's intended to give you a brief introduction to wetlands to supplement the material that's given on Blackboard. The first thing I want to ask here is, what is a wetland in the first place? Something that you should understand as you work on your team assignment. Wetlands, as it states here, are transitional areas between land and water. Scientifically, they're ecosystems that depend on inundation or saturation, where water is very close to the surface in the water table. Legally, as defined by federal law, they are areas that are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support particular kinds of vegetations and adapted for life in particular soil conditions as well. You'll see that the legal definition of a wetland supports the 3-parameter approach to wetland identification, having hydrophytic vegetation, water-loving vegetation, hydric soils, and wetland hydrology. Wetlands are, of course, very important, as you know from the basic environmental science you've had before this course, because they help to provide fish and wildlife habitat. This is particularly important in Alaska. They help to cycle nutrients. They help to improve water quality. They protect from floods and erosion. They help to sequester carbon. They're good for recreational purposes. And they also provide other ecosystem services that are of economic value. There are a number of federal laws that support wetlands, and I've listed those here. Generally speaking, these laws are administered by the Army Corps of Engineers, though the EPA does have some important veto powers over the Army Corps of Engineers. As a result of this, the Army Corps of Engineers is largely responsible for monitoring wetlands and permitting when any activity is going to take place upon a federally protected wetlands. Wetlands must be protected, and there also must be compensation for when they're lost. And again, the Army Corps of Engineers is largely responsible for this protection. When identifying wetlands, there are 3 things that are always looked at, as mentioned before: vegetation, soil, and hydrology. Wetlands are identified during the growing season. And there are a number of key field data collection techniques. They vary from region to region. The Alaska techniques and the particularities of Alaskan wetlands are identified in this field handbook that is published by the Army Corps of Engineers that is posted on Blackboard. There's also a wetlands determination data form that I would like you to examine as well. With regards to vegetation, if an area is to be determined as a wetland, it must be dominated by hydrophytic plants. In the videos you're going to watch, Justin is going to use a number of terminologies that help us to determine what is a hydrophytic plant or not. Obligate plants are those that are almost always found in wetlands. Facultative are ones that are equally likely to be found in wetlands or non-wetland areas. And then upland plants generally are found in non-wetland areas. When an area has a dominance of hydrophytic plants, it can be considered as a wetland. With regards to soils, soils are often very histosolic. They tend to have a lot of thick organic matter in them, as you'll see in the videos. They have a lot of dark surface layers, and when you get deep below the thick organic matter, which can be very difficult actually in wetland areas, you'll start to find blue, green, or gray soil layers. They also tend to have that hydrogen sulfide smell, a sort of rotten egg smell that many people identify with wetland areas, swamp areas, etc. With respect to hydrology, as you would imagine, there needs to be evidence of shallow ground or surface water. Water is generally ponding, or the water table is very proximate, within 12 inches of the surface. There's often evidence of flooding as well. Generally speaking, wetlands are found near water sources, as you'd expect, and have topography that traps that water in it. Wetlands can be investigated in a number of different ways. Wetlands are largely mapped throughout the United States, although they're not always as accurately mapped as they should be. There are lots of GIS map resources out there, including the National Wetlands Inventory. The municipality of Anchorage also has data, too, that will allow you to see areas that are mapped. But these often have to be field checked by field work through a delineation process, which you'll be learning about in the videos, where a wetlands delineator looks very specifically at vegetation, soils, and hydrology, and then uses a form to determine if an area is a wetland or not. There are all sorts of different resources that can be used to evaluate wetlands. As I've just noted, field data is quite important. As you start thinking about wetlands in the project that you'll be working on, I want you to expand your thinking about wetlands into the vegetation structure as well, which is closely related. You can do more research on vegetation structure by looking at existing EIS documents that I've given to you, as well as some of the other documentation that's included in Blackboard. Do your best. I understand that you are not fully trained professionals yet in delineating wetlands and identifying vegetation, but as environmental science students, everyone should be able to do a fairly good job of saying something intelligent about the wetlands and also the vegetation that are found in the area that you are to be looking at. Good luck, and I am happy to answer your questions.